Hi, the topic for this video is a continuation of lesson 4.5, which was multiplying and dividing rational numbers. That's a very broad topic, and even this half of it, dividing rational numbers, is so broad that I can't cover it in great detail. I want to do some review and then focus on the algebraic part, which is what will be something that's new to 8th grade students this year. But let's just do a quick review of division. In the same way that if you multiply two numbers with the same sign, if you divide a positive by a positive number, you get a positive number. If you divide a negative by a negative number, you get a positive number. And then a negative divided by a positive is negative, or a positive divided by a negative gives you a negative number. So negative 6 divided by 3 would be negative 2. 6 divided by 3 is positive 2. Let's take a look at different ways that we can represent division. We'll take that simple problem of something like 2 divided into 6. Could also be written as 6 divided by 2, or 6 with a division bar, which functions just like a fraction bar. This is a very common symbol in algebra. It's a preferred symbol for division when you're working with variables. A model for division is that it can be thought of as repeated subtraction. So how many times can you subtract 2 from 6? If you count the subtraction signs, you'll see the answer. And remainder 0, 1, 2, 3, remainder 0. Or another way to think of division is if you have 6 things in a set, how many groups of 2 can you make? So that's a really elementary but important review of what division means. What if we are dividing by a decimal number? So we have the question of how many times can you subtract 3/10 from 6? Well, it's more than 2 because you're taking a very small number from a relatively larger number. Another way to look at this, representing this with division, would be 6 divided by 3/10 this way. And then to make sense of the algorithm that we're going to review for this, you could remember, you can think of this as a fraction, although technically it's not. But you can multiply the numerator and denominator of a fraction by the same number. So this would be the same as 60 divided by 3, which gives 20 times. You're going to follow the rule that you don't allow a decimal number to be in the divisor of a fraction or of a division problem. So you're going to slide that decimal over. And what you're doing is multiplying by either 10, 100, or 1,000, or some multiple of 10. If I move it over one place, I'm multiplying by 10. I'm multiplying by 10. And if I multiply the divisor by 10, I have to multiply the dividend by 10. So the 6 becomes 60. If I put a decimal there at 6, it would have been behind the 6. So I'm going to go over there, and now I'm going to get how many 3's are in 60? And with the division algorithm, I can think of subtraction. Can I subtract 3 from 6? And the answer is yes. How many times? 2, with 0 left over. Some of you like to put that little arrow there. How many times can you subtract 3 from 0? Well, you can't do it any times. So there's the answer. Now, I didn't realize this is using some really easy numbers to work with, but that's intentional because I wanted you to focus on the process. So remember, you can't divide by a decimal number. You have to convert the decimal number to a whole number by multiplying. And whenever you multiply the divisor by, you have to multiply the dividend by. So let's move to fractions. Here's an algebraic definition of division as it relates to fractions. A over B divided by C over D will equal A over B, do the opposite division, and then use the reciprocal. Technically we don't want to call it the opposite, but it's sort of like that. Flip the C over D, and then you'll do AD over BC. If we have, you kind of use this intuitively. If someone asks you, what's half of 10? And remember, of means multiply. And with multiplication, we can switch it around like this. Most of you, if you think half of 10, will do 10 divided by 2, which would be 10 divided by 2. And if you examine this pattern, you'll see that it's sort of the opposite of this. We're going A over B times A over C equals A over B divided by C over D. 10 over 1 times 1 over 2 is the same as 10 over 1 divided by 2 over 1. This works both ways, but usually we use it to convert a division to a multiplication problem. But that's just a rationale, intuitive rationale of why this works. So with if I had 6/7 divided by, I'll just use a half here, that would be the same as 6 over 7 times 2 over 1, or 12 over 7, which would be 1 5/7. Before we get to working with an algebraic example, I want to remind you that if you have a variable to a power divided by a variable to another power, that's the same as, if it's x to the m divided by x to the n, that's x to the m minus n. So if it's x to the 8th divided by x to the 5th, that equals x to the 8 minus 5, or x to the 3rd, I'm sorry, x to the 3rd. This is how it would work. X multiplied 8 times, we write it out. 1, 2, 3, 4, 5, 6, 7, 8. X multiplied 5 times. And then just like in the last video, you can cancel an equal number of x's out. And y don't work. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5. 1 for 1, 1 for 1. Oh, not that one. Okay, so that gives us x to the 3rd power. Sorry, I got going a little beyond my means there. Likewise, you could go, if I have x to the 3rd over x to the 10th, well, it's a little bit of a problem because you're going to get a negative number. You would get x to the negative 7. You can actually go make it x to the 3 minus 3 over x to the 10, subtract the same number. Cancel out the same number of x's is basically what this is showing, which should be x to the 0 over x to the 7th, and any number to the 0 power is worth 1, so this would be 1 over x to the 7th. If you think about what would happen if you wrote that out, you would cancel out 3 x's in the numerator and 3 x's in the denominator, leaving you 7 in the denominator. So I'm going to take a look at, I think it's problem number 20 on page 89. Look here. Yep. Which is 12 x y to the 2nd power divided by 20 y over 3. The first thing that I can do to make this a little friendlier is to make that more like a fraction. I have a division here, so I know I can flip the 20y into 3 and get 12xy squared over 1 times 3 over 20y. Okay, now if you remember what we did with multiplication, we're good to go from the previous video. If I examine the numbers here, I see I've got the largest common factor, greatest common factor between 12 and 20 is a 4. So I can, we say, factor out a 4, or divide by 4. Divide 4 into 12 and get 3. Divide 4 into 20 and get 5. Another common factor are any common variables that you see. There's an x here, but there's no x here or here. So let's look at the y's. There's y squared here, and a single y, or a y to the 1st power here. I can take away 1 here, one of the y's, and 1 here, leaving not y multiplied twice, but y multiplied once. So I'm left with 3xy times 3, which should be 3 times 3, 9. And then the only remaining variable is an x. And then 1 times 5 is my denominator. I can leave it like that, 9x over 5. Or I could simplify the 9 over 5 and make it 1/4 x if I wanted to do that. But typically you would leave it just like this. Oh, I forgot the y. So I was kind of worried I might do that. So it's 3 times 3 is 9. x, y over 5. Right? That's really a quick overview of how this topic of dividing with rational numbers, covering positive integers and decimals and fractions and algebraic expressions.